right, so our last day of fun and new materials until next semester or next calendar year if you want to be tricky. Okay. I will still video the reviews, so if you need to review, you can go back through them again, but in terms of new stuff, today's it. All right, it says take out worksheet 11, 12, and 13, grab a calculator. You are going to need some graph paper for tonight's homework. So there's graph paper back there. All right, linear programming. We talked about this yesterday. Many applications in business and economics involve optimization. You do a ton of optimization in calculus too. The process of finding a minimum value or a maximum value for a specific quantity is called optimization. So what is something you would want to maximize? Okay, production, profit, okay. What is something you might want to minimize?
Waste.
Sure, waste, downtime on that production line, cost, yes, you want to minimize cost, okay. So you can find maximums and minimums using this process called linear programming. A two-dimensional linear programming problem consists of a linear function to be optimized called the objective function. Okay, yesterday's objective function for the bakery was the very end as you raced out the door, that profit function. Remember at the end, we had like $3 for one kind of cookies and $2 for the other. That's the objective function, what you want to maximize or minimize. I always write the objective function first, and I'm going to tell you why. It's a real silly reason, because then I'm done with those numbers, and those numbers don't confuse me the rest of the time, okay? So otherwise I keep looking at those numbers going, where do I have to use those? All right, a system of linear inequalities are called the constraints. I used that word yesterday, right? We only had so much frosting, so much dough, so much time. Those were the constraints. After you have shaded in, and we found that weird shaped little box thing with all the corners, that was where all the possibilities existed. That is called the feasible solution or feasible region. All right. Now, we did worksheet 12B yesterday, so I'm not going to take time to do 12A right now. This is the vertex theorem for optimization. Doesn't that just sound fancy? It says, if you have a linear programming problem and it can be optimized, an optimum value will always occur at one of the vertices of the region. So it will always occur at one of these. Now, it is possible, like yesterday, we are not going to do any more that have two solutions necessarily, and there's not one on the quiz. But do you remember yesterday there was two different solutions that worked to maximize profit at the end? Actually, if you have two solutions that work, everything in between those two solutions would also have the same profit. We're not going to worry about that because the one on the quiz is only going to have one maximize or minimize point that works. So here's the steps. It says graph the region corresponding to the solution of the system of constraints. So you graph and shade. Find the coordinates of the vertices, the corners. Evaluate the objective function to find the maximum profit or minimum cost or whatever it's looking for. These are the learning targets. So if at the end of the day, today, you aren't sure what some of this vocabulary means, please let me know. I can come back to them at the end, but I can write an objective function and a system of inequalities to represent constraints. I can graph the feasible region. I can find the vertices by graphing or algebra or matrices. We're going to do all those today, and then evaluate to find the maximum or minimum. All right, so we're going to start with some that give us the objective function. This is the objective function right here. Okay, that's this f of x thing, f of x, y. And they want us to find where both the maximum and the minimum occur for that function, but we don't graph that, okay? These are the constraints, and those are what we're going to graph. Now, we did not have to write the constraints this time, but we're going to graph them. I did not mention this yesterday, but there were two hidden constraints that were part of yesterday's problem. The hidden constraints were x is greater than 0 and y is greater than 0. Because we only graphed in the first quadrant, right? Can't make negative cookies of either kind. So these constraints are almost always part of a problem. Not always, but almost always. And a lot of times you don't remember to write them down. I'm not even sure. I think on the quiz, I put those two down so you knew that you didn't have to write those as part of the constraints. But most real life situations, we can't have negative. Okay, so we need to graph, well, obviously greater than 0 means it's above here, right? Y is greater than 0 means it's to the right of here, so we're in quadrant 1. We took care of those two. Now, to graph the first one, I would probably get the y by itself because it seems pretty easy to rearrange that one. Does that seem okay? Y equals negative 2x plus 10. So we start at 10, down to and over 1, and you know how well my tablet works, so graphing accurately is a nightmare for me. And you know how well Hofbauer draws lines. Okay, are we above or below that? It was a less than or equal to, guys. So below. So we're down to what shape right now? A triangle. But we have one more line to cut through. And this line is a little bit messier to solve for y. We could do it, or we could use intercepts. Remember yesterday? If I have x plus 2y equals 8, if I put in a 0 for x, it'll just say 2y equals 8, so y would be 4. If I put a 0 in for y, that'll be 0, so it'll just say x equals 8. I just find that faster than rearranging sometimes, but either way will work. So we have over 0 and up 4. Just be careful because I managed to plot the intercepts backwards half the time. Over 8 and up 0 is here. Now I need to connect those. Okay. For fun, let's use a matrix real quick and for a warm-up review to find the point of intersection. Oh, first of all, are we above or below that line? Yeah. So our shape is no longer a triangle, right? It's a weird four-sided quadrilateral thingy with 4 corners. Can anybody tell me 3 of the corners? 0, 0, 0, 4. Does everybody get that we don't need 0, 10? Because it's outside the feasible region. Okay, and this one down here is over 5 and up 0. Be careful because I write them backwards all the time. But let's use a real quick matrix to refresh our memory how we could find that ordered pair. I think we can tell where it is, but let's pretend. The 2 lines that was intersecting were the red and blue, or these 2. Everybody good? So if we want to find the point of intersection, we could put in a really little matrix and use RREF for a matrix that had 2, 1, 10, if I could write, and then 1, 2, 8. Okay, it's all positive, so maybe I can type fast. It is what size, guys? Okay, apparently I can't type fast because I can't even get it to work. Matrix A 2 by 3. Help me, what was it?
2, 1, 10, 1, 2.
Okay, this is just a good review of what we've been doing. Go back to the home screen, go back to matrix and over to math, RREF, because we put it all in one matrix. We didn't put it in 2, in which case we could use inverse. I got 1, 0, 4, 0, 1, 2. Everybody good? Okay. We didn't really need to do that anyway because we probably could figure it out, but it came out 1, 0, 2014, is that right, guys? So remember that meant X, actually the X is up here. X, oh, are they backwards? Thanks. Four and 2 like that. So X equals 4, Y equals 2 is this other intersection point, which does match what I had pretty well on my graph. We good? Okay, so the last thing we have to do is plug them into the objective function, each of them, and then figure out where the maximum and minimum occur. I usually do a little like chart for that to keep, then I don't have to rewrite 1,000 things. So my corner points were 0, 0, 0, 4, 5, 0, and 4, 2. The function I'm putting them into is what, guys? Mine's off the top already. 3x minus 2y. And then I'm going to get out a value, and I'm going to figure out where there's a max and min. Okay, so 3 times 0 minus 2 times 0 is a big fat 0. 3 times 0 minus 2 times 4 is actually a negative 8, right? 3 times 5 minus 2 times 0 is a 15. And 3 times 4 minus 2 times 2, 12 minus 4 is positive 8. Yes? Okay, so I'm going to write a little sentence over here since this is notes and we want it to make sense. The max occurs at 5, 0. No, you know what? I'm going to write that a little different. Just kidding. I write a maximum of 15 at 5, 0. Does that seem right, guys? And then a minimum of negative 8 at 0, 4. Now, on the quiz, it's only going to ask one thing, and it's going to be an application problem. Actually, I'm not sure that's true. There might be one where you have to do this as well. I think on the one you just get asked for all the corner points. Because on the actual application problem, guys, you don't have to finish it. You just have to write the constraints. I think I talked to some class about this because I don't want to double whammy you, right? If you can't get the constraints right, you won't be able to graph it, and you won't be able, so I'd have to like fail you on 1,000 things. All right. You try this one quick. You try it on your own. Graph these two, and then find the corners of your area. I'm gonna stop the recording, and I'll start. All right, so I graphed the blue line, went through 0, 4, and 4, 0. Then I graphed the green line using the intercepts, and it had to be below both of those, so I got, again, this little four-sided area down here. 3 of the corner points were easy to find because they were X or Y intercepts, and then I have this 4th one. Can anybody tell me algebraically a quick way to solve this without bothering to type it in my calculator? If I have an equation that says X plus Y is less than or equal to 4, you could, but that would involve a bunch of moving things around. How about, yeah, X plus Y equals 4. Could I do a negative of the next one? I don't care about the inequalities, but it would be negative X minus 3Y equals negative 6, and then add them together. I get Y is 1. And then if I plug the 1 back in up top, I'd have X plus 1 equals 4, so X is 3. Did anybody else do it and get 3, 1? Okay, I did elimination. Does that make sense? You could have done a matrix. You could have done substitution, like Martin, you know, get the X's by themselves and set them equal to each other. Whatever way you want to do to find that point. That's why this whole chapter was about systems leading up to being able to find these points of intersection. All right, objective function. You don't have to make a little chart if you don't want, but we have X plus 2Y, and we need to put in 0, 0. What will that give us out, guys? 0. If I put in 0, 2, that would give me out 0 plus 2 times 2 are 4. If I put in 4, 0, I'd get 4 plus 2 times 0 is 4, right? And then 3, 1 gives me 3 plus 2 times 1 would be 5. So a maximum of 5 occurred at 3, 1. And the other sentence, guys? Minimum of 0 at 0, 0. Okay. Got it? So there's a question like that on the quiz where I give you all the constraints. You just have to graph them and find the corners by whatever method you want. It may or may not ask you to maximize. I can't remember. But there's also one like this where you have to come up with the equation, the constraints. I was going to say restraints. It's talking about leather belts. I guess you could tie someone up, right? A company wants to add belts and wallets to its production line. They make leather products right now. A belt requires 2 hours of cutting time and 6 hours of sewing time. Wallets require 3 hours of cutting time and 3 hours of sewing time. The cutting machine is available 12 hours a week, okay? So maybe we're using that to make some other leather product right now, but it's free 12 hours a week. And the sewing machine is available 18 hours a week. Belts would net us $18 in profit and wallets would net us $12 in profit. How much of each should we make to maximize our profits? Okay? So like I said, I always do the objective function first, the one about the profit or cost, because then I can cross those numbers out and I don't need to worry about them anymore because the constraints can be tricky. All right? What is our objective function? If X is the number of belts and Y is the number of wallets. Do you have that down on your paper already for you? Okay. So, how much do we make on every belt? And how much on every wallet? So what am I writing? Okay, everybody good? So I'm done with that whole sentence, so those numbers don't have to confuse me anymore because I get confused easily. All right, now, this is where it gets a little confusing. I usually go through and I say, okay, what are the things constraining us? Well, we only have the cutting machine 12 hours a week. Does that make sense? So something has to be less than or equal to 12. Cutting, what does it have to do with cutting for a wallet and cutting for a belt? Okay, so 2 hours of cutting time for a belt would be 2x. And if we made a wallet, it would take us 3 hours per wallet. But those were out of 2 different sentences. Do you see where this can be a little bit tricky? Okay, now we have to go back and do sewing time because it has a constraint of 18 hours a week. So less than or equal to 18. What do you know about sewing for a, what are we doing first? Belts? 6 hours of sewing for a belt and for a wallet? Okay, so we got to graph this. Is there a graph or is it already done for you? Oh, good. Look, magic. Okay. How could we have found that point of intersection? Yeah, matrix. Can I take a commercial break to remind you how we did them yesterday? How could you rewrite 2x plus 3y equals 12 and 6x plus 3y equals 18 as a matrix multiplication problem? 2, 3, 6, 3, xy equals 12, 18. And then, oh, I don't know why there's a line there. Because it's over 18, but it's not really a fraction, Hochbauer. Okay. And then when, I can't do it without the line. Okay. So when you put this in matrix A as a 2 by 2 and this in matrix B as a 2 by 1, then I have to type inverse of A times B, right? And it would give me a little 2 by 1 that would be my XY, which apparently would have come out 1.53, which is kind of weird, okay? Now, the question becomes, and then they put those corner points all in, and the maximum occurred here. So the maximum profit of $63 could be made by making and selling 1.5 belts for every 3 wallets per week. The reason it's okay that it came out a decimal, okay, this is how much we're going to make in a week. Could we leave a belt half finished and the next week finish it and then, okay. So we're just trying to maximize our profit. It's not like we're going to sell a half a belt, but in 2 weeks we'd have 3 belts to sell, right? Because I had 1.5 each week. Okay, moving on. It is possible for a linear programming problem to have multiple solutions or no optimal solution. Do you have this example? Okay, so they graphed all this. Oh, let's just fill in these numbers real fast. They found all the corner points. Okay, they're labeled over here. They put this one in. If they put a 0, 0 in, they get 0. What is 6 times 2 plus 3 times 4, guys? 6 times 3 plus 3 times 0 is 18. 12 and 18 plus 6 is also 24. Did I do that right? So 2, 4 had a maximum and 3, 2 had a maximum. So therefore, any of the solutions along that line would work. So they say all of the points on this line between 2 and 3, anything in there could work. That's kind of like the one we did yesterday, but I'm not going to give you one like that in a quiz, so I'm just going to skip. Is that okay? I'd rather practice some more. Ew, do you have this one? Why? We don't need to do another one of those, do we? Wouldn't you rather set up a word problem? Oh, let's do this one. Okay. Manufacturer produces roller skates and ice skates. Apparently they have time spent assembling and checking and packaging the skates for sale. The profit per skates are there as well. Okay. Tell me something. Aislinn, tell me something. Anything. You can give me a profit equation. You can tell me what you want X and Y to represent. You can give me a constraint. Okay, so number of roller skates that we make. I assume it's pairs, but we'll go with that. Pairs, roller skates. Okay. Haley, tell me something else. That's supposed to say pairs. Pairs of ice skates. Okay. Kaden, tell me something. No, it's what profit has to do with these numbers right here. So our profit or objective function, which they like to write f of x comma y, you could just write profit in my mind, would equal what? Can you set that one up? Roller skates are x, remember? There you go. Everybody good with that one? Okay, like I said, I get that guy out of the way because that's not confusing to me. Okay, then it gets a little more confusing, but this one is the chart helps a lot. Okay, we have a maximum of time of 200 minutes on the assembling line, right? So we have to state less than or equal to 200 for assembling. Anybody tell me what that equation looks like? What? Yes, because right here it says for assembling, roller skates are 5, ice skates are 4. So this chart made it real easy to make this one. And the other one is, anybody, the checking and packaging one? less than or equal to, right? 120. Okay. I'm graphing fast. There's two hidden constraints. We can't make greater than or equal to 0 and y is greater than or equal to 0, both x and y, right? Which is pretty much assumed from the little graph paper they gave us. Now, I'm not real confident we can make this fit nicely, but I'm going to try. So the 5x plus 4y is 200. Let's see. If I put a 0 in for x, it'll say 4y equals 200. 200 divided by 4 is 50. How'd I do? So 0, 50. Whoa. Yep. Pretend that first dot wasn't there. The second one would be when y equals 0. So it would say 5x equals 200, which would be 40. So over here at 40, 0. And below. Okay. Then I'll try this one in blue. If x is 0, it'll say 4y equals 120, which would be 30. Yep, can't read that. But 0, 30, okay. If y is 0, it'll just say x equals 120, right? Okay, is that going to help us? I feel like that's not on our graph paper. Okay, so that wasn't as helpful as we thought. What else could we do? Yeah, we could rewrite it. So if we move the x to the other side, it would say 4y equals negative 1x plus 120. And then do what? Divide by 4. We'd have y equals negative 1/4 x plus 30. Now, these aren't counting by ones, but does it matter when you go to graph it? If you go down 1 and over 4, if you go down 10, wouldn't you go over 40? So there's another point right there that it's going through. So I don't really know what it looks like, but it's below that line. Okay, corners, anybody? 0, 0. One more that's easy. 40, 0. Okay. I would do this algebraically. Can you just subtract those two equations from each other, guys, to get rid of the y's? By subtraction, you would have 4x equals 80, right? 5x minus 1x would be 4x. 4y minus 4y would be 0. 200 minus 120 would be 80. So I get x is 20. And if I put it back in, maybe the bottom one, I don't know, 20 plus 4y equals 120. I'd have 4y equals 100, y equals 25. Okay, we're trying to maximize profit. This was our profit. I don't have much room. Can you guys type for me? 30 times 0 plus 40 times 30 would be 1,200. 0, 0. I think I got that one. 40, 0. Isn't that also 1,200? Okay. 2025 would be 30 times 20 plus 40 times 25. 2,200 is my guess. So that's probably wrong. What is it? Oh, yeah, I can't add. I got that now. Okay, 1,600. So, how many roller skates and ice skates should be manufactured to maximize profit? We should make, I always do we like I'm part of the problem, but we should make what?
20 roller and 25 ice.
To maximize profit of how much? $1,600, yes? Okay. The one on the quiz is like number 7 on worksheet 13. I think we have time to do that one. Can you flip to worksheet 7 or worksheet 13, number 7? Okay. This is a ridiculously dumb question. I realize that. You can blame me. I totally made it up. Mr. Big and Ms. Small are starting a company making remote control vacuum cleaners. I probably wrote this 15 years ago when no one had remote control vacuum cleaners. It was like thousands of dollars to get one. And now, does anybody have one at home? I don't have one. Like those little Roombas or yeah, anyway. I don't have one. Yeah. I told you the story about my dog tearing up my carpet. No? Anyway. We don't have to record this story, but that's my fear, is that the Roomba would get a piece of the carpet and I'd come back and it would just be all, you know, how a carpet frays. Yes. The Roomba would be dead and my carpet would be destroyed. Okay. Mr. Big and Ms. Small starting their company. They will make big vacuums and small vacuums. So what are X and Y? Number of big vacuums. And number of small vacuums. Okay. They have only enough materials to make at most 6 big vacuums and at most 8 small vacuums each day. That's actually 2 equations right there. What do you know about big? Big has to be less than or equal to 6. Okay, I'm gonna use a different color. Small, Y, has to be less than or equal to 8. It takes them 2 hours to assemble a big and 1 hour to assemble a small. They have at most 16 man hours in a day. So that's our icky, more complicated equation. What does that one look like? $2 for a big, or 2 hours and 1 hour for a small, and less than or equal to 16 hours. Okay, I did give you the 2 hidden constraints already. All right. Then the profit, which I always do first, except I never read the question until now. What is the profit?
120 for big and 100 for small.
So you can do that in any order you want. I just like getting those numbers out of the way usually. You don't use that till the end of the problem, right? Okay, don't graph the profit expression. All right, constraints. I have read X is less than or equal to 6. What is an X equals line? Vertical or horizontal? It crosses the X at 6. I don't know if we count these. I think I'm gonna have a lot of trying to count those. Okay. And it would be to the left of that line, right? Okay, I used green for this one. Y is less than or equal to 8 means we have to be 2, 3, 4, 5, 6, 7, 8-ish. I don't know, below that. All right, then I have a pretty blue color here for this one. How do you want to graph that one? Intercepts or Y equals? Okay, if I put a 0 in for X, it'll just say what? Y equals 16. If I put a 0 in for Y, it'll say 2X equals 16. So we'd get... Is anybody confused about that? Because I'm not showing work. You're okay with putting the zeros in? Okay. So I have 16 and 8. This was 6, so 8 this way would be here. This was 8. 16 is somewhere around there. Oh my goodness. How many sides does our area have? Well, yes, 1 side, 2 sides, 3 sides, 4 sides, 5 sides, right? So 5 vertices. Okay, 3 are easy. Can anybody give me one of the easy ones? Oh, you are good. Okay, some more. Anybody remember what this one was? That was a green line. So y was 8, so it's 0, 8, right? The red one down here was x is 6, so that's 6, 0. Okay. This is pretty easy algebraically if you know something about this, guys. What is true of every point on that green line? Y is 8, right? So can we put an 8 into the blue equation? 2x plus 8 equals 16 would make x 4? Oh my goodness, that 4 had issues. So this is 4, 8, right? This one right here, where the green. Okay, how do we find the other one? X equals 6. So if I put x equals 6, I'll have 2 times 6 plus y equals 16 would be 12. Subtract 12, don't I get y equals 4? So this is x is 6 and y is 4. All right, do you have enough blanks? I kind of remember that I messed up this question.
You have 3 printed ones, and then you look at the drew one and print it again.
Okay, yeah. So I don't think 0, 0 is going to be our maximum profit because we'd get $0, right? What about 0, 8? Into this purple equation up here would get us out what? $800? I'm just trying to do them one at a time here. 6, 0 would be 6 times 120, which would be maybe 720. Anybody checking me? Okay. Then we got the 2 that are weird, right? We got 4, 8, where we make some of each. That would be 480 plus 800. 1280 is that one? And then I'm totally out of room. The last one, what was that last ordered pair? 6, 4? And I covered up my equation. How much is it? 6 times 120 plus 4 times 100? 720 plus 4, 1120. Okay, so they should make oh yeah, that's what we put in, right, to get the 1280. I was looking totally wrong place. 4 big and 8 small vacuums to maximize profit of what? Okay, seem okay? My favorite topic. Okay. There should be some back there. Are there extra homework checklists back there, guys? Okay. Make sure you get the review for the quiz too. We'll go over that tomorrow. But I will answer homework questions tomorrow, so